So this is another slope field question. We're going to sketch in slope field segments. So it says, consider the differential equation dy by dx is equal to 1 plus y over x, where x is not equal to 0 because we can't divide by 0. Part A says, sketch a slope field for the points indicated. So that's what I'm going to start with first. I'm going to plug in x and y's to then calculate the slopes. So in this case, if I start at y equals -1, I can see that I get 0 in the numerator. So at y equals -1, I'm going to get horizontal line segments for slopes of 0. And then if I move to y is 0, then we can see that we have 1 over the x value, so it becomes 1 over -2. So I end up with negative slope of -1/2 through there. 1 divided by -1 gives me -1 slope through here. 1 divided by 1 is going to give me positive slope through here. And then 1 divided by 2 is going to give me positive 1/2 slope through there. Okay, so then those are my slope segments for those points. And then I have at y equals 1, my numerator is going to be equal to 2. If x is -1, I'm going to end up with 2 over -1, so I'm going to get a -2 slope here. And then at x equals 1, y equals 1, I get 2 over 1, so I get a steeper line segment through there. Okay, so I've now sketched my slope field through the points indicated. This is not the entire slope field, but it gives me an idea what the slope field might look like. Part B, for the particular solution y equals f of x to the differential equation with the initial condition of f of -1 is equal to 1. So that means x is -1, y is equal to 1. And we need to solve this for that initial point. So we need to, that blue coordinate, -1, +1, is going to allow me to calculate the plus c. So to do this, we're going to separate our y's with dy's. So we're going to go dy, and then the 1 plus y is going to go with the y. And then we end up with dx, and the dx moves over to the right-hand side algebraically. Again, this has to be separable by times and divide. So we get dx over x, and then integrate both sides. I end up with log 1 plus y, and that's equal to log of x, and then plus c. Okay, so I want to solve for that plus c, but I can put the plus c in with put it together with the log x, and I can do it in this way. Now, we can still solve for plus c on the outside, but at some point, we need to get rid of the logs. And to get rid of the logs, we can't have that plus c. So I'm going to deal with that plus c by putting it inside the log. And I'm going to do that by expressing that plus c as plus log c. Okay, and I can call that c2 because just so that it's still a c, log c2 is still a constant, but that c is different than the original c. And then I can rewrite this as log 1 plus y equals log, and then using log properties now, that c can be put together with the other log. And so now I just have one log on the right side, one log on the left side, and now I can get rid of the log. So before, I couldn't get rid of that log with that plus, any kind of plus on the outside. Now I can drop my logs. So this becomes 1 plus y, and you're going to drop the absolute value here. 1 plus y is equal to c2x, and I can then solve for my constant. So I'm going to plug in my constant, my x and y coordinate, and I'm going to solve for that constant. So y equals 1. And again, it's not that important that you keep track of that c2. I just wrote it as C2 just to make sure it's really clear that it's different from the original C, but it's not that important. So I'm going to plug that in and then solve for the C. So I end up with 2 divided by -1 is equal to C. So C is equal to -2. Okay, so my solution, y equals f of x, the f of x is going to be -2x minus 1. The domain of this function is going to be all real numbers except for x equals 0 because my differential equation I can't divide by 0. And if we think of these linear equations that pass through this function, where this with any starting point of x equals 0 will give us vertical asymptotes. So notice that these lines all seem to pass through the y-intercept of -1. Okay, so they're just going to be all different equations with slopes of different slopes, in this case -2, and a y-intercept of -1. And we can't have one going through 0 because that will give us a vertical line.